Earth is far stranger than we imagine. Earth is home to forests, oceans, and deserts we know well but hidden beneath the waves. Inside sealed caverns and across the most hostile landscapes are ecosystems so bizarre that they challenge the foundations of biology. Some exist without sunlight, some thrive in toxic chemicals, and others have remained isolated for millions of years. Drawing from studies by NASA, NOAA, UI Smithsonian, and major research institutions. Here are the strangest ecosystems ever discovered on our planet. Hydrothermal vent ecosystems, life at the gates of hell, deep in the ocean, at depths of 2,000 to 3,500 meters, lie hydrothermal vents towering mineral chimneys spewing superheated chemical-rich water. These environments feature complete darkness pressures 250 to 350 times atmospheric pressure, temperatures up to 400 degrees Celsius, water rich in hydrogen sulfide. Lethal to most life forms, yet entire communities thrive here. Giant tube worms, Riftia ponchiptula, albino shrimp, and yeti crabs survive through chemosynthesis, where bacteria convert toxic chemicals into energy no sunlight required. Two, the Movile Cave, a world sealed for 5.5 million years. Movile Cave in Romania has been isolated from the outside world for 5.5 million years. Its air is low in oxygen and high in methane, carbon dioxide, and hydrogen sulfide, toxic environment for most animals. But inside lives a completely unique ecosystem with 48 endemic species, including blind spiders, pale scorpions, long, translucent worms, a highly specialized venomous centipede. This ecosystem relies entirely on chemosynthetic bacteria that feed on methane and sulfur compounds, forming the base of its food web. Three, the Danakil Depression, Earth's most alien landscape located in Ethiopia. Danakil is often called the gateway to hell. It is one of the hottest, most chemically extreme environments on Earth. Average temperature, 46 degrees Celsius. Pools of natural sulfuric acid, pH approximately equals 0. Hypersaline lakes. Toxic gases such as chlorine and sulfur dioxide. Only a few strains of extremophilic microbes survive here. Some pools appear completely lifeless in extremely rare situation on Earth. For Surtsey Island, a brand new ecosystem born in 1963. Surtsey, off the coast of Iceland, emerged from a volcanic eruption between 1963 to 1967. Scientists have had a unique opportunity to observe how an ecosystem forms from nothing to 1963. Sterile, volcanic rock and ash, late 1960s. First, bacteria appear 1970s-80s. Mosses and lichens colonize 1990s. Flowering plants arrive present day. Insects, birds, and seals inhabit the island. Surtsey is one of the best documented examples of ecological succession on Earth. Five, the Red Sea brine pools, deadly underwater lakes. The Red Sea hosts more than 25 deep-sea brine pools, underwater lakes of ultra-salty water with salinity 4 to 8 times normal seawater, zero oxygen, high concentrations of heavy metals, toxic hydrogen sulfide. Almost no animals can survive inside these pools, yet certain archaea thrive, using chemosynthetic sulfur metabolism. Six, pitcher plant microecosystems, a whole food web in a single leaf. One of the smallest, but most complex ecosystems exists inside the leaves of pitcher plants, Nepenthes, and Sarracenia species. Each leaf functions as a miniature pond containing water-decomposing insects, bacteria, protozoa, rotifers, larvae, mosquitoes, detritivores together. They form a complete microbial food web, cycling nutrients much like a real lake. 7. Antarctica's dry valleys, the coldest, driest ecosystem on Earth. The McMurdo Dry Valleys in Antarctica are considered the most Mars-like place on the planet. They receive almost no liquid water, experience temperatures as low as -40 degrees Celsius, and endure katabatic winds up to 320 kilometers per hour. Despite this, microbes survive inside rock pores, thin films of brine, subglacial saltwater pockets. These life forms persist using minimal light and chemical traces. What extreme ecosystems teach us about life? These bizarre ecosystems demonstrate that life is far more adaptable and far more astonishing than once believed. Life can survive without sunlight, without oxygen, in boiling water, in acid, hypersaline, brines, and freezing deserts. By understanding Earth's strangest habitats, we gain insight not only into biology, but also into the possibility of life beyond Earth on Mars, Europa, Enceladus, Titan, and beyond.